This is the second experiment in the sequence telluric transference of electric power. As you can see, we're out in the field now. I've taken one of the same receiver coil, the cylindrical coil. We're about 2 miles away from the lab itself. I've set up with the normal things. I've got the same radio receiver that we were using. I've got the VNWA set up on the small table there, and we can see the coil. If I just pan around, the coil there, the wire goes down here and into this lake that we've got here. That's where we're going to do these measurements. Okay, so what we've got set up is we've got the transmitter set up for 10 watts, and we're going to see if we can get a reception. I'm going to leave this running, and then I'm going to call the lab and we'll take some measurements. Hi Rob, I've got the camera running. Now I just did a little introduction to the scenery and the setup, and now you've got your setup there for 10 watts, aren't you? Okay, alright, do you want to I'll have to move the camera in a minute, but first of all just turn on. Okay, so we're receiving 6. We've got maximum sensitivity and we've got a signal strength of 7 bars. Just turn off. Okay, this is at 1.86 megacycles. Turn on again. Yes, up to 6. And I've got the radio connected by the BNC connector directly to the primary of the receiver coil. And we've got four turns. And I'm speaking for the camera here as well. And we did a VNWA test to get the frequency right. We're not using a tuning capacitor here, we're just using the unloaded coil to start with. We'll add a tuning capacitor later. So what I'm going to do is I'm actually going to bring the camera around. I'll bring it by hand so we can actually see what's going on in the setup. Okay, so yeah, that's fine. Here's the vector network analyzer. We've got that connected up. Well, we haven't got it connected at the moment, but we used it to tune the receiver. Okay, so I've moved the camera so we can see the Sony ICF 2001D receiver. That was the same scanner from the 80s, Sony scanner that we've been using in the first experiment. Okay, Rob, if you want to turn on. Okay, so we can see we're up to 6 bars, and turn off. And back on again. And if you can just confirm you're at 10 watts at the transmitter. Is that 10 watts at the transmitter, Rob? Okay, you're just adjusting, huh? Okay. And off. Okay, I'm just going to take a little bit more. Just going to see the lake down there. We've got an aluminium plate down in the lake. That's for the camera, Rob. We can just see it there down in. It's about 2 foot by 1 foot, and that's connected by about a 4 AWG microstranded silicone coated, the normal heavy duty flexible ground wire that we use for these experiments. Okay, so back with the result. So you can turn on, Rob. That is okay, and turn off. Now what I'm going to do is I'm just going to actually disconnect the aerial, and we see what it could receive on its own. Okay, and on, Rob. Is it on now? Not receiving anything. Let's just take a pause. Okay, so I've disconnected the BNC from the side, so we're just relying on the antenna of the receiver. You want to turn back on. Is that 10 watts? I'm not picking up anything, it's just me touched to. Okay, so if I touch the antenna and improve its reception slightly, there is just slight, one can slightly hear the tone, but no sensitivity lights have come on the receiver. So now if I reconnect, so reconnected, and now we're back to 6. Okay, and off, Rob. Okay, I've set the camera up in a different position now on the tripod, rather than trying to hold it myself whilst we do the experiment. So at the moment we've got the Sony ICF is set, the aerial is extended maximum. I'll just show that. There we go. All the way up and back, and the BNC at the side is connected into the tuned antenna. The antenna is tuned to the 1.86 megacycles that we're using at the transmitter, in the same way that we did for the previous experiment. We've got the aluminium earth plate down into the small lake here, and that is also connected by a 4AWG microstranded silicone coated wire that we normally use, these heavy duty flexible wires, to the bottom end of the secondary coil. So we're going to run it with 10 watts from the transmitter. Rob, if you just want to turn on. Okay, so we've got sensitivity turned up to maximum. We're getting 6 bars. Let me just try tuning that slightly. I'll just, yes, up to 6 strong. I just reduced slightly the length of the telescopic aerial on the top end of the secondary coil. And off again, Rob. Okay, and back on again. Okay, good. So we're stably at 10 watts. We're 2 miles away. We've got this antenna connected down into the river with a reasonable grounding plate. So what I'm going to do is I'm going to disconnect the BNC, plug. No difference at all. If I hold it, now I can hear the tone slightly, so if I put my hand and add myself to the antenna, then I can actually get, just in the background I can hear the tone coming from the transmitter, but there are no sensitivity lights. If I plug the aerial back in, this BNC here, basically just connects directly to the primary. If I plug that back on, and we're back up to sensitivity of 6, just to make sure that the secondary coil is involved. In this, I'm going to put my hand close to the secondary coil, and that basically damps it all down. Let me just pan out and show that. So if I just bring it up here so we can get both in, hopefully the tone will be coming out on the camera. Now if I put my, just adjust that. Okay, if I put my hands near the secondary, there, no bars, tone's hardly audible. Back, put my hand, same will be true. Secondary, obviously I'm adding myself as the part of the antenna because the primary is directly connected via the BNC. 4 turns we're using here. Obviously I'm damping it down, but not so much with the secondary. Secondary is the high Q resonator here. That makes a big difference. All the way down to no bars. And that's with only 10 watts over 2 miles. Now if I unplug the wire at the bottom that goes into the lake, if I unplug that, also we're going to lose all our bars. But we also have to remember here that the frequency has also changed because we've changed the wire length. So to do that, to check that, I basically need to increase the wire length at the bottom, but I'm not going to put it down into the lake, so we make a comparison like that. Okay, Rob, you can turn off for the moment. So what I'm doing now is I've got the VNWA Vector Network Analyzer, DJ SAQ, that I normally use, connected to down the same BNC. So it's the same wire that we were using connected to the Sony ICF. I've still got the ground plate connected. I'm just going to take a sweep and here I have transmitters running at 1.86 megacycles. And I've got the, very interestingly, I've got the tune set to the parallel mode. So not the series mode, but the parallel mode. It's for the camera. So what I'm going to do now is I'm going to disconnect I'm just going to disconnect the plate in the lake, and I'm going to attach a single wire at the bottom which is not connected, or is not so firmly connected like the plate to ground. Obviously it's still laying on the ground. I'm just going to check the change in frequency slightly. The parallel mode has shifted up slightly to 1.91, so I'm going to need to increase the length of the antenna. Just shift that back down again until we get the parallel mode. It's now almost right. Not quite. Just reduce its length slightly. Stand that. Just check that. Oh, 1.8. Yeah, that's about the same. 1.86. So now I'm going to reconnect to the ICF radio receiver, and exactly the same way. Let me just check what the camera's showing. Yeah, the camera's got that in. Okay, Rob, do you want to turn on? So now we are at 10 watts coming from the transmitter still. Rob, can you just confirm it's 10 watts? 10 watts, okay, good. And I have retuned the antenna system so that it's running exactly the same frequency, but with a single wire just laid out on the ground. It's not going into the river. Let me just check. No, that's even worse, it's better reception. Okay, and I can hear the tone slightly in the background, but there are no sensitivity lights on. So the sensitivity lights, we had 6 before when we had the plate down into the ground. I've retuned the antenna so the parallel mode of the secondary is at exactly the same frequency, and we're really not receiving very much signal. So I'm going to put it back to the ground again, unplug it, I'm going to keep the transmitter on, and immediately it's gone right up to sensitivity 4. We need to retune slightly so we get the frequency right. It's right down, it's about a little bit out there, about there. 5 bars. 5. Obviously every time I touch it, it damps the signal down. About 5. Seems to be about what we can get right now. Okay, and off, Rob. Good, so it's off, the signal's gone. Turn back on again. There we are. Now, actually, my body is now further away from. I've come back round close to the camera again, and we're back up to 6 bars. Just put my hand on there just to check. Yes, that's the effect with the secondary. So now that's very interesting. So now we've reconnected it to place in the river. We know the frequency is the same because I use the vector network analyzer to show the characteristics of both systems, and to make sure that the parallel mode, so that is the unloaded parallel mode. Remember that the secondary coil, Tesla resonator, or Tesla Magnifying Transformer, basically has both a series mode and a parallel mode. And out here in the field, the best place that we've currently found to run this with the biggest signal is actually at the parallel mode. And I've got that parallel mode tuned to 1.86 megacycles. And Rob, can you just confirm that you're at 1.86 megacycles at the transmitter? Rob? We are, okay, good. Okay, you can just turn off for the moment. Okay, good. So what's very interesting about that is that in past experiments, we have been able to conjecture and show that there is the parallel modes of the Tesla resonator are more associated with the LMD, the longitudinal magneto-dielectric modes. When we did high efficiency transference of electric power over 1.5 meters and over 11 meters single wire, we were able to, again, conjectured that the LMD mode was established between those two, which is why we were able to get such high efficiency. But now out in the field, I mean, obviously we're not getting the same kind of transfer efficiency as we would with a single wire. We demonstrated that in the previous experiment. But in this case here, it's very interesting to note that tuning to the parallel mode, as I said before, I believe more associated with the LMD rather than the TEM, the transverse electromagnetic mode, actually gives us a much better reception when we put the the single wire, well, not the single wire, but the wire at the bottom end of the secondary coil with the aluminium plate down into the lake. And that was then also compared with a single wire, that's a 10-meter single wire, just laid out on the ground here, and the antenna adjusted, the tuning of the antenna adjusted, so that the frequencies are the same. And so I'm just going to run that experiment again and do some active tuning. So Rob, if you want to turn on, and then what I'm great, 10 watts, so we're back to the six bars on the sensitivity of the signal. So I'm now going to take out where it's gone completely. I'm going to put in the single wire that's at the end. We're showing 1 bar. Let me do a bit of retune. Let me see if I can find an optimal tuning position. It's not there. That could be too low a frequency. Let me reduce the frequency right down. 1 bar. I should think that probably will put the series mode at about the right place. Let me just increase it little by little. Back to where the vector network analyzer said it was best, which is about there. That's the length. Step back from the antenna. Doesn't show anything there, but when I put it right back down, I think we can get one there. We can get 1 bar. We can get 1 bar with it totally retracted. And then let's go back now to the plate down in the water. Tune it back to the LMD mode, or the conjectured LMD mode. Step away from the antenna, and we're back to sensitivity of 5 almost. Okay, Rob, if you want to turn off. Rob, if you turn off. Rob, turn off. Turn off, Rob. And on again. Okay, slight adjustment, yep, tuning it back, and we're back to six bars. And we can get that, we can only get that when we've got that wire down into the plate, and it's not with the plate on it down into the lake, and it's not a product of the wire length. I've got the wire, I just substitute it with a wire tuned to the same, which doesn't go down into the lake. So we are getting here at a distance of around about 2 miles from the lab. We are getting a much stronger ground wave than we are getting sky wave. In the previous experiment, obviously we were still very much in the TEM near field. We were inside, the distance between the 2 labs was inside 1 wavelength. And there we were obviously finding that the sky wave and the ground wave we demonstrated were contributing about equally to the received signal. Now we're out in the field. The sky wave, or what we can receive without connecting firmly down into the ground, and by that means I mean putting a ground connection down into the water, the sky wave, the best we could do with an additional length of wire to get the tuned frequency right was 1 bar. It was 1 bar on the Sony receiver, and now we are receiving between 5 and 6. Can you just check, is it 10 watts still, Rob? Still 10 watts, great. So we're receiving between 5 and sensitivity between 5 and 6 bars with the through the ground wave. So a considerable difference. Much stronger through the ground wave than it is through the sky wave using this system. And interestingly, the best tune point here was the parallel mode of the secondary. Okay, good. Okay, and off, Rob. Okay, so we're out on location again for another experiment. This time we're just over 8 miles from the lab. We have the same setup. This is a reservoir which has an incoming river and outgoing feed. I'll just show you how it looks. Okay, so it's a nice big body of water. And we're going to be putting our ground connection down in there into the water. So the ground connection is this aluminium plate here, connected by, it's about a 6 AWG microstranded cable with silicone coating, same as what we used before, and that will go down into the water and connect to the bottom end of the secondary coil. Once again, we've got the same setup with the vector network analyzer, and we're going to be taking some radio receiver and also some power meter measurements here as well. So first of all, I'll just put this down. I'll just get the ground down into the water. Doesn't have to go out too far. That into the bottom. We've got our aerial at the top there. Okay, so we've put the aluminium plate down into the water. You can see it there off at the edge. I'm just going to swing back round so we can see the whole experiment. And then we're going to connect up the vector network analyzer and make some measurements. We're going to be running this again at the same 1.86 megacycles. That's what the same transmitter setup as we were using previously with the specialized ground system. Okay, so I've set up the vector network analyzer and I've connected it to the primary coil and taken an initial scan, and we are set up the same as where we left off on the previous experiment. So the lower parallel mode is set to 1.86 megacycles. I'll show these results on the right up, so one can see. I think it's pretty hard to see what's on the computer screen. Yes, so I'll show those results on the right up. The series mode, let me just have a check. The series mode frequency is about 2 megacycles. I'm just going to tune slightly, just the wire length slightly. So I'm going to put it on continuous sweep, and I'm going to make some small adjustments. To the aerial length, to the wire length. Very close. Almost there, should be. Right, so I'm right on the peak now. Same as before. And we'll just measure. We'll just measure the wire length. It's 36. Same as what we had before. So 36 centimetres. Just note that down. 1.86 megacycles. Now I come back, it's just slightly adjusted because I was near, very sensitive, and I was near the. So let me make another adjustment on this. So running continuous, slightly low, so just a little bit longer. Let me come away from the antenna. Yes, that's better. That's right on now. And I'll just measure again, base. 38. So 38 centimetres at the top end puts the lower parallel mode. There's no tuning capacitance, we're not using that loading at the moment in balance mode. We'll probably do that later. So, just making note of that. 38 centimetres, 1.86 megacycles, and I'm just going to save and store what we're doing. So let me just save that. Okay, so we've got our radio receiver set up, and we're going to try some reception experiments. I will just call through. Hi there, Rob. Can you hear me? Okay, good. We're ready to do first try. So I've got what I've got set up here at the moment is I've got I've set it up to the same best position that we had it when we were down at the meadow. And I've connected the radio receiver, so we'll see whether we get any signal through. So you can, when you're ready, you can set up for 10 watts. Yes. Yes. And then tell me when you're ready. Okay, you can go ahead. And off. And back on. Yeah, I can hear the tone. It's quite low. Let me just unplug. Yeah. Okay. Without the antenna in, I can't hear it at all. It's still on 10 watts, sir. Okay. Let me just try a few variations here. And it's same frequency, yeah? Okay, and off. And back on. Alright, so let's go up to, I'm getting a very small tone here, but not any bars at the moment. So if you could go up to 20 watts. You're on 20 watts. And off. And back on. Okay, I can still hear the tone very slightly. It could go up to 50 watts. Yeah, tone's getting a bit stronger now. Okay, I'm just going to try a few things. So we've got the radio receiver, the Sony ICF, as we used before, connected to the receiver via BNC into the custom port, and I can hear the tone. We're running at 50 watts at the transmitter. I can hear the tone, but there are no bars illuminated, so the signal strength is still quite low. I've got it up to maximum sensitivity, so I'm just going to unplug the BNC, let it receive via its own aerial. Okay, now I don't hear the tone at all. Just change the orientation. Yeah, I can't hear the tone at all with the cylindrical coil disconnected, so I'm going to reconnect. Now I can hear the tone. Just, yeah, when I detune, putting my hand on there, the tone also goes away. Okay, Rob, if you can turn off. What I'm going to do is I'm just going to tune to a different position. I want to try to get the best possible receiving position for the receiver coil. So I'm going to tune to some different positions. So if you just bear with me, I'll tell you when to turn back on again. You can keep it set up for 50 watts at the moment. No, keep it off. Keep it off. I'm just going to do some tuning changes. Right, so I need to reduce the frequency. No, I need to increase it actually. So let me put quite a lot more on. We're going to bring the series mode down to quite close actually. Okay, just make another adjustment. It's a little bit too. Yeah, it's good, isn't it? Yeah. I've had a few dog walkers so far that were interested, and a couple of swans come to investigate what was going on. Yeah, they kind of swam into a little thing to have a look at everything. No, the swans. Okay, so I've got it retuned. I've retuned to the series mode now. I'm just going to measure the antenna length and see if we get any better results here. 80 centimeters. So I'll just write that down and save the results. So just bear with me a minute, Rob. Write it down. So 80 centimeters is 1.86 megacycle. Series mode. That is a lower parallel. Okay, so that as well. Okay, so what we've done is we've retuned. We've increased the length of the wire length on the telescopic aerial at the top end of the secondary coil. That has reduced the frequency of the secondary, so we've brought the series fundamental mode down to 1.86 megacycles. It was at 2 megacycles before when we did the previous test, because we were using the lower parallel mode in order to do the first test. So we've got that retuned. I'm going to put that back over onto the radio. Turn the radio on, and I'm just going to check everything's recording. Yes, it looks okay. Okay, Rob, so if you want to turn on and set 50 watts. Go and hear the tone again. Tell me when you've got 50 watts set. Okay. Alright, so and off again. And on. And off. Okay, so it's actually slightly less than when we were at the parallel mode, but not by much. I can hear the tone, but just a little bit. I will just check it without the antenna connected, so we're just relying on the radio relying on itself and its own antenna. Okay, and on. Yeah, I can hear it very, very slightly. Hardly at all. Okay, and off. Reconnect the receiving coil, and on. Oh yes, it's much stronger. So much stronger with the Tesla receiver coil connected, and that was at the series mode. So what I'm going to do now is I'm going to actually add some loading capacitance and set it in the balanced mode, and then we try the same reception again. So you can turn off now, and I will just do some retuning. All right, thanks Rob. Okay, so I'm going to add some loading capacitance in on the primary to get us to the balance point. To do that, I'm going to use this capacitance box here. I'm just talking for the camera, Rob. Let me place this in line, and then we'll add some additional loading capacitance to balance our. So I'm going to start by adding just let's see, around about 500 picofarad, and we're going to balance those parallel modes as we have done in so many of the experiments before. Okay, that's a little bit too much. I'm just going to back off a little bit to 400 puff. Just wait for it to rescan. Closer, down to about 230. Too much. It's too little, sorry. About 270. 290. Scan, get a few revolvings, look at that balance of that mode. It's a little bit high, so I'm just going to go down to 80, and then up to 85, 285 puff. See how that scans. Side. Very fine adjustments. Good. 282. Okay, good. So the balance mode, that is where the upper parallel mode and the lower parallel mode are balanced in magnitude. That is the lower parallel mode from one of the parallel modes from the secondary coil and the other from the primary coil. So with a 80 centimeter extension, series mode is at, let's just check again, 1.86 megacycles, and we've got 282 picofarads loading to produce the balance mode. I'll just store that. Okay, save that. Then we're going to reconnect. We're going to leave that connected, and we're going to reconnect still using the series mode, but with balanced parallels. Okay, Rob, do you want to turn on again at 50 watts? And off. And on. So nominally about the same. And off. and on again. We just disconnect the antenna. Yes, the tone goes away. Much less sensitive. Tone constantly, less dependence there than the parallel mode. Put there, it doesn't detune. Series mode is staying. That actually improves slightly using myself as an additional aerial. Disconnect at the bottom. Can't hear it anymore, but the tune frequency will have changed, so we'll have to check that with a single wire there. Okay, and off, Rob. Okay, what I'm going to do is I'm going to do another tuning, okay? Okay, so what I'm going to do now is, we just tried it at the series balance mode. I'm going to reduce the antenna length back down, so as that we go down to the parallel mode, but I'm going to do it in a balanced way. So with the loading capacitance to see whether that increases our signal strength. So first of all, I'm going to set back down to 38 centimeters, which is what I was using at the beginning. 80. Let's go right in and then out. More. Okay, we use that as a starting position. Take another scan. Set. Look at what we've got. Okay. So to get down, we would have our lower parallel mode is already below 1.86 megacycles, so we will have to reduce the loading capacitance a bit in order to see whether we can actually bring it down. So let's put that on continuous. I'm going to change that first of all down to 182. Okay, that's close. A little bit through the balance. 150. Trying to get the lower mode down to 1.86. I think I'll have to reduce the wire length. So let me take this right down to start with. Help us to get down at the right frequency. Shift the wire length. Okay, so almost now. The series mode is now shifted to 2 megacycles. The lower parallel mode is just below 1.86. So let's just reduce the tuning capacitance a little bit more. Down to 90. Almost there. 80. 70. 60. Okay, so 60 there puts it right at the peak. So in actual fact that would be, because there is a background capacitance of 26 picofarad for that box when 0 is set, that will actually be 86. So I need to write down for 282, that will also be 20 plus 26 picofarads. So now we have adjusted right down to the minimum wire length. We just measure. 18. So 18 centimeters on the telescopic aerial. That's fully closed. So 18 centimeters. We've set the lower parallel mode to 1.86 megacycles using loading capacitance of, on the primary, parallel loading capacitance with the primary of 60 picofarad plus 26. Just export that. Okay, save that. Okay, so we can connect back to the radio. Okay, Rob, you can turn on to 50 watts again when you're ready. Okay. Right, now that's actually a stronger tone. That's the best tone so far. And off. And back on again. Okay. Big difference when you damp it down to the parallel mode. But tuned to the lower parallel mode there with loading capacitance of 1.86 megacycles, that actually gives us the best reception of tone for the current system. That's 50 watts in at the transmitter. Obviously we will go up a bit there. So just to recap, so I've retuned the system. I've retuned the system receiver Tesla coil with some loading capacitance from this box. 60 puff plus 26, that's 86 picofarads, which brings the lower parallel mode. It's not balanced because we would have to reduce the transmit frequency in order to do that, and then I don't want to adjust the transmitter at this stage. I want to keep that at 1.86 in the ammeter band. But is an improvement where we had no loading capacitance, and although we're still not getting the signal strength bar, the sound of the tone is clearer and is also a bit louder. Let's just check again by taking off the... You can hear a little bit of the tone, but much stronger when you put this back in. So some of it is coming by the air, some of it is coming by the ground. It's just... Okay, Robin off. Okay, this seems to be the best position so far. So let's go up to 100 watts. Now to do that we'll use the linear amplifier. So you get set up and let me know when you're ready. Yep. Okay, so what we're going to do at the transmitter, we're going to use the linear amplifier. That will take us up to we'll go up to 100 watts, and then we'll go up some higher there and see what our signal is like then. That's just being adjusted at the moment at the transmitter end. Okay, off. Okay. You got it on, huh? At 100 watts. Sorry. Okay. All right. Go up to 200. Okay, so the tone is... I don't know how the tone is coming out on the camera, but it's getting louder. Here, 200 watts, okay. Just okay, and go up to 400. Yes, okay. Okay, so we've now got 1 bar signal strength of the receiver. 4. Okay, so we've got 400 watts going in at the transmitter, and we are on 1 bar of signal strength with a clear tone. Now, so quite a lot of power going in. Let me see if I can demonstrate that. Okay, hold it steady, Rob. I'm not sure that will come out. No, let me keep it out. Readjust. No bars. Move that off. No. Keep it on. Just try low impedance. No. 1 bar. And as myself, damps it down. Damps it down. Try some manual tuning. See if that makes a difference. Back to 1 bar. Take out the loading. Okay, without the loading we're up to 3 bars now. So better without the loading. So took out the loading. We are now at 4 bars. And off, Rob. And back on. Yes. So at 400 watts in at the transmitter, we've got 4 bars coming through. Let me just disconnect, see how it looks through the air. Nothing. No bars being received on this system without the Tesla receiver connected. Connect the Tesla receiver. I'm almost up to 5 bars. 4 bars. Okay, and off, Rob. I'm just going to move the camera in a bit closer so we can see that result. Okay, so I brought the camera in closer so we can actually see the receiver when it's running. Okay, Rob, if you want to turn back on again, maintain the same power input, 400 watts. Okay, so we have 400 watts going in. We have 4 bars of signal strength. I'm just going to check what we're receiving by disconnecting. So disconnect, and the BNC, let me just pan out so you can see that. Look, I've disconnected the BNC from the edge, so it's just now receiving through the air as the receiver is, and there's no bars connected. There's no bars received on the signal strength. I'm going to reconnect the BNC. And we're back to 4. So reasonably high power coming at the input, but we are able to make a good reception. It's about 8 miles away at a naturally fed reservoir, so it's connected to river as well. Okay, Rob, go down to 200 watts. Just go back in a little bit so we can see that. Tell me when you're ready. How's that? Okay, so we've gone down to 200 watts and we are down to 2 bars of power. And Rob, go down to 100 watts. Okay, so 100 watts, we are on 1 bar of signal strength received. So a reasonably linear relationship. So Robert, go up to 200 watts again. back up to two bars. Okay, so 2, almost 3. Okay, roll up to 400. Okay, so 400 set, so almost 4, back up to signal strength of 4 bars. Yeah, 4 bars seems stable. Okay, and off. Okay, good, so we can see that we can do the, we are receiving the signal. We need to make a comparison of what we're going to receive if we just receive through the air. So here we are, if we remove the B and C connection at the side here, we'll just pan out so we can see. So if we remove this cable, which takes us to the primary of the Tesla receiver, then we can't hear the signal at all. So in removing that, the radio is just dependent on its own aerial. It's a fairly long aerial. I'll just show that. But it's unable to receive, as demonstrated, is unable to receive any signal strength. You can't even hear the tone in the background of the noise, and there's no signal bars. So if we connect the Tesla receiver, which is properly tuned to the lower parallel mode, it was better without the loading capacitance, and there we were able to a signal strength of 4 bars. I'm just going to go back to our 38 centimeters just to see if that actually improves us even further, since I did remove the loading capacitance. Okay, just go on, Rob. 400, just if you just turn on, same as before. No. Tell me when you've got 400 set. Okay, so that's actually worse. That's actually 2 bars. So it looks like we pretty much had the most optimum position. Let me just see, let's tune that dynamically, see if it improves. It's getting louder. Up to 3 bars. Up to 4. So actually we had the optimum position already. Let me just pan out. So we can see, if we take a look at that aerial, the telescopic aerial is now minimally extended. When I had it out at 38, which was our starting point, we got just about between 1 and 2 bars. And I extend it back into its optimum position. We're back up to 4 bars. And off. Okay, so that really does seem so far as the most optimum position of tuning. We've got no loading, parallel loading. We've got the telescopic antenna at its minimal. And what we do need to do, so that is using the Tesla receiver, which is able to receive the signal quite strongly, whereas the radio on its own is not able to do that. And we also need to make a comparison as to how the air part of the Tesla coil is also, so there is a combination of the ground wave and there's the sky wave. At the moment we have everything connected, so we're receiving both the ground wave through the telluric medium and also the sky wave. So I need to add a single wire. I need to remove the plate, which is down in the reservoir, and add a single wire and retune so we're at the same frequency, and then we see how much we're receiving just through the sky without the telluric involved. So let's just set that up. Rob, I'm just going to retune and then we'll make another run. Okay, so first of all, we're just going to take a scan of our current setup. It will help if I reconnect it. So let me reconnect that to here. We have a look where we're actually tuned to. Okay. I'm going to save that. Alright, so we've saved that where we are now. So if I put the marker back on the peak as the lower parallel mode, that's actually set to 1.89. And that was where we actually got the best signal reception through at 1.86. Probably the impedance match of the Tesla coil is optimum at that point. So now I'm going to put the single wire in and I'm going to retune so that we are in the same position, starting at 1.86. It's a 10 meter single wire that goes at the end. Let me just, I'll just pull the camera back. No, I'll actually leave it there because we'll want to see what the result looks like. So I'm going to lay out the single wire on the ground. Let's just pan out fully. So I'll set it down here. I'm going to lay out the single wire. 10 meter single wire, not connected to anything at one end. No loops in the wire. Disconnect the plate and connect the single wire. So now we've got a 10 meter single wire connected. It's just laid on the ground. It's not connected to any kind of ground point. Just going to scan the vector network analyzer just to see how that's changed. So it has, the wire length has reduced a bit. So now the peak is up at 1.92, the lower parallel mode. So I'm just going to bring that down as a starting point to 1.86 by increasing the wire length at this end. We can always reduce that to find the optimum position like we did before. And we'll scan that. Okay, that looks better. So that brings the wire length to the lower parallel mode is 1.82. So it's actually a little bit low. Bring that down a little bit. Actually, I'll put this on continuous scan. I can just do it. Okay, so we set the marker on 1.86. Which is, okay, that's about right. So with a 10 meter single wire, 10 meter single wire, 1.86 megacycles for the lower parallel mode. We'll just measure the antenna length so we can reset that if we need to. 46. So 46 centimeters. And so this now we are just looking to see what's received as in the skywave. We're not connected down into the water. We've just got a single wire at the end laying on the ground. Let me refocus. and here. Okay, Rob, do you want to turn back on, set 400 watts? Okay, I can hear the tone. So that is obviously coming through from the skywave. We'll just wait until it's set. Got 1 bar of sensitivity at the moment. On the receiver. Okay, so we're set on 400. We've got 1 bar of sensitivity on the receiver from the skywave its own. I'm just going to do a little bit of tuning just to see if we can improve on that. 2, down, 2. Okay, so we've got to get 2 bars, minimum extension. We'll just go out gradually. Okay, back down to 1, going away from our optimum point. So the best is, again, 2 bars at 400. We'll have 4 when we have both the skywave and the ground wave. Okay, so turn off, Rob. Just turn back on without readjusting. Okay, yes, back to 2 bars. Okay, I'm just going to compare that again when I put the telluric channel back in. So, Rob, if you can turn off. I'm going to swap the single wire now for the plate down in. Okay, Rob, if you can turn on without readjusting. And we're back up to 4. So that was also the optimum tune point with the telescopic antenna fully in, and we can see that the, which is convenient actually, that the single wire and the telluric plate, or the plate in the water, were actually tuned at about exactly the same point. So with the skywave and the ground wave, we have a signal strength of 4. Yep, signal strength of 4. You can turn off, Rob. Off, and I'm going to again switch back to the single wire. Okay, turn on. We're back to 2 bars. Okay, and off, Rob. Switch back again. Let's just get the camera in so that we can see how see what we're doing. Just going to pan out, come back to here. Okay, so currently I've got the telluric plate connected and on, Rob. Back to 4 bars and off. And plug in the single wire. And on, Rob. And 2 bars. And off. So what we see basically is that with both the ground wave and the sky wave, we are at 4 bars sensitivity. It's 400 watts input power at the transmitter, 8 miles away. With just the sky wave, that is, we're using the Tesla receiver tuned at the same frequency with a 10-meter single wire, which is just laying on the ground. It's not connected into the ground. There's no metal into the ground, or it's not in the water, or anything like that. Then we are able to get 2 bars, and we attribute that to the skywave portion. So about half and half, which interestingly was actually a very similar result that we gained when we were doing the comparison between single wire and telluric medium in that first section when we were doing it in the lab, between the two labs. That is a very similar result. Okay, good. So we're going to take a break, and then we're going to have a look at doing some power meter measurements. We set up the power meter, the Hewlett-Packard 435B, with a sensor. We can see that there in the picture. Here's the meter and the sensor. That's connected using the same cabling and the same tune position. And we did run this 400 watts, but we were not able to detect any power on this meter at all. Now this power head is from, I think, it's up to 3 watts, I think, of power. Yeah, and it's the lowest range on here is 300 microwatts, and we weren't able to detect anything either with the telluric channel, the metal plate down into the water, or with the single wire. So we need to run these experiments again next time with a more sensitive power head. Also bearing in mind we're into a 50 ohm load here, so we're into a low impedance, where with the radio receiver obviously we are into a high impedance. And what we'll do is I'm just going to focus in on the meter and we'll actually run those. Let me just get that in the center. That's on the 300 microwatts range. Actually, I might just swing the camera around in front so it's easier to see. Let's just pan that out. That's a bit better. So we get focused on that. Straighten it up a little bit. There we are. Okay, that's better. Just reset that. Set to 0. We're on the most sensitive. Actually, let me just show the range we're on. There, we can just see at the top there. 300 microwatts, 0.3 milliwatts. The calibration of the meter has been checked with its 1 milliwatt power reference, so it is correctly calibrated. And we'll just get the transmitter turned on, and then we'll see. What we can see. So let me just do that. Hi there, Rob. Okay, we'll just run a few last tests. What I've done is I've focused the I've got the power meter in, and we'll do some just do a few runs on that. So what I want you to do is you to turn on again, maintain at 400 watts, and let me know when you're ready. Okay, so that's at 400 watts, and we haven't got any. We're on the 300 microwatt range here, the meter. No real shift of the needle, so, or no shift at all. You just turn off again. And on again. Yeah, no shift at all. You're at 400 watts, huh? Okay, so if you just turn off again, I'm just going to change to the single wire. That was with the telluric connection into the water. Now I'm going to put the single wire in. Okay, I've got the single wire plugged in now. Okay, turn on. 400 watts. No. Yeah, no movement at all. And turn off. And turn on. And turn off. Okay, I'm just going to check the calibration of the meter whilst we're actually running, just to make sure that everything's right. So I'm going to put it up to range 1 and just connect the probe to the power, and we should get right up to full scale deflection, which we do right onto the cowl point at 1 milliwatt. So the meter is correctly calibrated and operative. So let me go back in, take it out, connect that back to the receiver, Tesla receiver. Okay, Rob, you want to turn on again? Are you at 400? Yeah, there's no real, well, there's no movement of the needle at all. That's with the single wire, so turn off again. Just put the telluric connection back in and turn on again. Okay, and turn off. Okay, I'm just going to pan out there, and I'm going to bring the radio receiver back in, just as a reference to make sure we are still receiving what we had before. To position this. That's there. I'll put this on here. Disconnect, and we take the signal put that back to 1.8, turn that in a little bit, come in again on that. Focusing on the radio. We've got the telluric channel connected at the moment. Okay, so Robert, just hang on a sec. Let me just position this slightly better. Okay, so if you want to turn on, keeping the same power, 400. Okay, yeah, we're back to 4 bars as we were before. Great, that's 400, is it? Okay, and turn off. And then we go back to the, I'm just going to change back over to the single wire. Just do a comparison. Okay, and turn on again. Back to 2 bars, just for the skywave. Okay, turn off. to the telluric and turn on. Yeah, back to 4 bars. Okay, so the consistent result, so we can receive it, and you can turn off, Rob. So we can receive it through the skywave and the ground wave with the Sony receiver, and also just through the skywave. So that was 4 bars for the skywave and the ground wave, 2 bars of sensitivity only for the skywave. But when we were connected now to the power meter on its most sensitive range of 300 microwatts, it was properly operated and calibrated, we could get no deflection of power. So it's a very low level power that we're receiving. And in another field trip, there is a more sensitive power head that goes right down, much lower than the dynamic range of the one that we're currently using. And we can use that, and then we should be able to pick up a deflection of the HP power meter, but with the current sensor that's not possible. So that's really all of the experiment for today. We're just over 8 miles from the lab. We've run from 10 watts up to 400 watts on the transmitter as before, and we've done a range of receiving and reception experiments using this particular Tesla receiver coil, tuned at different positions, and the summary of that is the best tuned position appears on the lower parallel mode. That's actually much what we also discovered in the last field trip that we did when we were 2 miles from the lab. We got the best results at the lower parallel mode and with the minimum aerial extension, and that was tuning the system to the optimum number of the highest sensitivity of received tone. Okay, good. Right, I think that's everything now, Rob. Okay. Yep, I think the experiment was good. We tried everything that we wanted to do, and then we just make the plans for the next field trip from here. All right, great. I'm going to I'll pack up, and I'll see you back at the lab. Okay, thanks. Bye bye. That concludes our field trip for the day. I'm going to get packed up now, and we head back to the lab. Just show you the pan around so you see how everything was set up. Can't see it, but the single wire goes back up there. This whole was on a cart. We made a custom cart which this aerial sits on. It makes it very easy to move around. We can pack up the whole lot onto there and just wheel it back to the car. And we'll be taking some measurements further afield. Now we're going to go much further afield to the sea. That's a distance of about over 100 miles from the lab, and we'll be taking measurements there as well, and that'll be in a subsequent part. Good, so this is telluric transference of electric power at 8 miles and at 1.86 megacycles.